Hello, and the killer Sudoku was a bit well, simpler than I was expecting today. I've got a bit more time, so I thought we'd take a look at a telegraph puzzle for a change. You can see on the screen, hopefully there's a range of Sudokus that the Telegraph publishes in terms of difficulty. It looks like gentle's the easiest, then moderate, then tough, and then something called Diabolical. So I thought we'd have a look at that and see how difficult it is. Okay, let's do it. So I've discovered on the site how to make pencil marks. You do it by sort of clicking on the top of boxes. As you can see, I'm able to write in ones here in this bottom 3x3 box to indicate one can only go in two positions, especially on the harder puzzles. I think it's normally, if you want to solve them with any sort of efficiency, certainly a good idea. And you can see we can put in an 8 here. That's good and useful, and that means we can make some more pencil. Oh, no. More pencil marks over there. Okay. It's sort of these runs of 3 digits in a 3x3 cage like this. We need to use these as much as we can. They're only giving pencil marks at the moment, but at some stage I imagine that they'll be useful to the solve. We can put in a 3 over here. You can see that now. Look, the first use of our pencil marks. We can put a 3 in here. That's going to be correct, and that allows us immediately to write the 5 in as well. And we can write in pencil mark 5s over here as a result of that. Okay. Just taking a look there to see whether or not I can see anything more useful than that. I'm not seeing anything terribly clever there. Again, I'm trying to use this 1, 6, 3 combination. You can see I can place 4s into there, and actually look at that. That's going to allow me to place a 4 into this position, and that's going to chain for the 4, 8 and the 5. So I can place a 4. My pencil marks mean I can place an 8. My pencil marks mean I can place a 5. Now all of that ought to be fairly helpful. It's going to allow me to place a 5 into this position now. This 5 here. I can imagine that there's going to be a 5 in one of these two. Pencil mark it just to show you. And then this 5 here stops there being a 5 in this particular cell. So it has to go here. Similarly, there has to be a 5 here. Can't quite see which of these central cells is going to take the other 5. The 5 that's left. Now when we get sort of a run like that, we need to make sure that we use these numbers as fully as we can. So we also got this 8. You can see that's going to allow me to place an 8 here, and here, and here, which is another quite useful set of deductions. So now just look at the top row. You can see we need to place 6 and 9 in some order, so let's write that in. 6 and 9. We can pencil mark 6 in to these two positions here, and we can pencil mark 9s in down here, and 9s over here. Okay, so I don't really feel like we've had to do anything. I don't feel this has been diabolical yet. Sometimes the reason that these puzzles are hard is not necessarily the early stages of the solving. It can quite often be some horrendous trick you need to use close to the end. So now I'm looking down column 4. I can see immediately we need a 1, 3 and a 7 to place. So I'm looking at this cell. Now there's a 3 and a 3 here, so this definitely can't be a 3. Now that's actually going to resolve this entire column now, because the only place a 3 can go is in this cell here. So that's a 3. That means that's a 7, and this is a 1. And hopefully that will allow me to make a bit more progress with some of the rest of it. You can see I can pencil mark 3s over this side. Can't really use this 7 for anything terribly useful. And somewhat annoyingly, this 1 is also not proving terribly helpful. can see the 249 that are open in this 3x3 box. There's just no help for those anywhere, so we can forget about that. So where do we look now? Where would I be looking if this was? I'd be looking at column 8, certainly. I can see I need a 2 and a 7 in column 8. I can also see quite quickly that there's nothing doing. Neither of these positions, you know, are being checked by a 2 or a 7, or anything that really looks useful in terms of a 2 and a 7. So I have to try and remember that they're restricted cells, but I don't think that's going to be the place where I need to make the next bit of logical progress. So where should I be looking? Oh, there's a naked 3 we can place there just by simple Sudoku rules. That gives us that 3 as well. Let's put those in. Not sure how much help it'll give us, but certainly shouldn't look a gift horse in the mouth. I'll probably have a look now at this row. We can see 1, 2, 4 and 6 need to be placed. Okay, so 1, 2, 4 here. So this is a naked 6, which we should write in. Let's see if that gives us anything. It gives us some more pencil mark opportunities. 6 and a 6 there. Yes, okay. And a 6 and a 6 here. I don't know why this has got 3's in it. It shouldn't have 3's in it. Like that, I think. Okay, so now we're going to have to think again. And in fact, can we use... Yeah, there's a little bit of advanced logic we can use here. This is nice. So let's have a look. You can see that we've narrowed this to be a 1 or a 2. I mean, we said earlier this was a 2 or a 7, and this was a 2 or a 7. So if we look at the pattern of 2's that we have in these 3 squares, yeah, that got me wondering whether I could sort of create the edges of a box here. Because if I can conclude that this is the only square in this column that can take a 2, and you can see I can conclude that because there is a 2 here that prevents there from being a 2 in either this cell, or this cell, then I have the sort of edges of a rectangle, which are the only cells within their 2 columns that can contain 2's. Now you may say, well, how can that help you, Simon? Well, the reason it helps is that no other, if there was a 2 here, there would be a 2 here, and if there was a 2 here, there would be a 2 here. So it should be obvious that a 2 cannot appear anywhere in this cell, this cell, this cell, this cell, this cell, or this cell. And I bet you that's helpful. And you can immediately see it is going to be helpful because, in fact, we could have put pencil mark 2's into these 2 positions. And you can now see this cell here can't contain a 2, so this is going to give us a 2 up here. And in fact, from that, a lot of things are going to fall. So, because when we write in a 2 here, let's show you, I can immediately write in a 9 over here as well. And I'm thinking that's going to be useful, as we can now place 9's over here, these 2 positions. What are we left with? 1's and 7's into these 2 positions, which we can't quite resolve yet. 1, 4, 6, 7 down here. Forces a 4 over into one of these 3 cells, but nothing doing there quite yet. You can see we can pencil mark not 2's but 1's up here and here. Like that. Need to remove some of these old pencil marks really, though they can be a bit confusing. Now, I had to take a break from the puzzle, and I've just come back to it now. I'm trying to sort of recreate where we were in the logic, and I have to say this is looking to me quite difficult to make progress. So I'm certainly not seeing anything using the standard notation that we recommend. So this might be one of these examples where we actually have to look at or think about a different form of notation to make progress from here. So what I'm going to do is I'm just going to pause the video now. I'm going to remove some of the extraneous pencil marks. So for example on this, we don't need to leave this 5-8 obviously here. I just find that it's confusing me. So I'm going to remove all these and then we'll have another look. Okay, now I have noticed something now, but it's this is quite an unusual piece of logic. I certainly don't think we've covered this in Cracking the Cryptic, and we've been going for about a year. And it's definitely not something I'd recommend in terms of speed solving, and that's probably why we don't come across it very often. So what did I do? Well, I was looking at this row of the grid, row 3, because I can see that several of the cells in this row are quite restricted. So what I'm going to do now is I'm just going to fill in all of the options for the open positions in some of the cells in row 3. You can see, for example, this has to be a 1, 4, a 6 or a 7, but we have a 1 here because of our earlier pencil marks, and this 4. So this cell is a 6 or a 7. This cell is a 1 or a 2. I'm not going to look at this cell. This cell we already done some work earlier. This was quite restricted. This could only be a 2 or a 7. This cell is also reasonably restricted. You may say, why on earth am I looking at this cell? But I'll explain it in a minute. So this cell could be 7 or 9. And this cell here is the other one I want to look at. And because of these 1 pencil marks down here, this cell can be, what, 2, 6, 7 or 9, I think. I think that's right. Now, you may say, well, how does that help me? Well, it helps because there is a very unusual thing going along. If we look at this cell here, in fact, I'm going to start somewhere different. What I was thinking about was, can I eliminate a 2 from this collection of numbers here? And the reason is I will explain at the end, but I think perhaps it's easier to explain that final piece of logic after I've got rid of the 2 here. And believe it or not, I think there's an X-wing that can get rid of this 2, because if we look at these 2 positions in row 2, and we ask ourselves, where can a 2 go in row 2? You can see this 2 here prevents it from going in here, here. It can go here, it can go here, it can't go here. And let's slide down the grid and ask ourselves the same question in row 8. Okay, so again, a 2 cannot go here, it can go here, and it can go here. So here we have an X-wing on 2s. This cell, this cell, this cell, and this cell. Now, again, for the reasons we talked about earlier with the other X-wing, this means that there cannot be a 2 anywhere else in columns 6 and column 7, which means we can remove the 2 from this cell, like that. And now something very interesting happens, but to spot it, perhaps the easiest way to analyze it is to imagine what would happen if this cell here was somehow in this position, because then you'd have, in a row, you'd have a 6, 7, 9 cell, a 6, 7 cell, and a 7, 9 cell. And I think it's very obvious to anyone looking at that, that's a triple on 6, 7, and 9. Or if it was all in the same row, we would immediately say, well, there cannot be a 6, 7 or 9 anywhere else in the row, and that would allow me to remove the 7 from this box here. But the cunning thing about this puzzle is that that logic works exactly the same way. As regards this cell here, it is seen, if you like, this cell here is seen by 3 cells which contain a triple. It's seen by this cell, which contains a 6, 7, 9, this cell, which contains a 6 and a 7, and this cell, which contains a 7 and a 9. Therefore, it's impossible for this cell to contain a 7, because, well, you can quickly see why. Let's imagine this was a 9. If this was a 7, this would be a 9, this would have to be a 6, and this cell couldn't be filled. So in effect, these three cells here operate as if they're sort of a triple in the same row as regards this cell here. Now that means this cell here cannot be a 7 and has to be a 2. So let's write that in and see what that does. I'm pretty sure it's going to completely break the puzzle open, because if there's any more advanced logic needed for this puzzle, it's bordering on the absurd. I mean, what I will say is this is rated Diabolical, and those of you who've been following the series or seen us, we do a lot of solving of super fiendish puzzles in the Times, and there's nothing we've seen in the Times that's remotely approaching this level of difficulty. Now, it could well be, in fact, that I've missed a simple step here. You know, when I'm solving on the computer, you know, unfortunately for you guys, you're relying on the logic I see. And it could be that, you know, if we were doing a computer solve, we'd find that I'd just missed a hidden single somewhere that would have broken the puzzle open. In which case, sorry about that, but at least you've got to see some more interesting techniques. But certainly, if this is the way you're meant to, you know, solve this particular puzzle, this is really very hard. It's very interesting, but also very hard. So that allows us to do that. Now you can see now that 1 here really does help. It means we can place a 1 here, a 1 here, 6 here. I'm tempted not to go any further because the puzzle is just it's clearly basically solved now. You know, we're filling in a lot of the difficult numbers that we couldn't get before. So I think we'll stop there. You can finish it at your own leisure if you like. There's 7s here. Now look, that 7's going to go in there. That's going to force 1, force 6. The whole puzzle is that was the critical stage. So something a bit different, something very interesting, and I hope this was, you know, as I say, a good episode of Cracking the Cryptic for those of you interested in the logical way to approach some of these very, very difficult puzzles. I'll see you again next time on Cracking the Cryptic.